Okay. So next is scatter plot. So what scatter plot pairs up with the value of two variables in a data set and display them as the points in a Cartesian diagram. So the way we used to draw graphs, the data scatter plot looks the same. It plots all the value on a canvas. So let's first get the duration. Okay, so one variable is duration, another variable is waiting. This is the syntax. Plot is the command with duration and waiting, and then there are labels x label and y label. Cool. So this is the scatter plot of two observations. So y-axis is the time weighted, x-axis is the eruptions, and all the observations being plotted. So to get a feel of what exactly is the scatter plot is giving me is it is giving me a significant linear relationship between these two variables. So how do I feel a linear relationship using a table is I can quickly use a regression line function, which is AB line, and I can just see it. So what's the slope and everything, I can see it from this line, saying that these two variables hold a linear relationship and they are directly proportional to each other. Okay, so next is quick functions on the statistical measures: mean, median, mode, kurtosis, quantile, whatever we have gone through in the lecture, box plots, variance. So we will quickly see their formulas in this session. Okay, let's start with the simpler ones. Mean of durations. Mean is a direct function available. We have the mean 3.4. Median is also directly available. Median is the function. Median is the 4 for the data. And how do we know median is 4? When we do the box plotting, then median would also be there. How we'll see the different quantiles. Quantile itself is a function. We have to put a data set into it. Yeah, and you get 0, 25, 50. So 50 is 4, which is a median. We also got a median. 0 is 1.6 to 25% is this 75. So this is the upper quantile, this is the lower quantile. Range would be upper minus lower, and this is 100%, highest number basically. This is lowest number. Range is the largest value minus is the smallest value. So let's see what is the range. Yeah, so we have a range which is 3.5 here. Let's see what's the quantile range. Interquantile range of the observation variable is the difference of its upper and the lower quantiles, 75%, 25% respectively. It's a measure of how far apart the middle portion of the data spread is in the value. So let's see. So IQR is the function that can give you a quick interquartile range. That's 2.2915. Overall range in the data is 3.5, but when we see interquantile range, which is 2.29. Box plot, we know definition that it gives you a quick observation of outliers, where is the mean and what is the spread of data. So let's go ahead and quickly plot the box plot. So we'll do a box plotting of duration. Sorry. These are the values. Let's do a box plotting. True. So we have a box plot here. A quick interpretation: highest value is something 5 plus, lowest value is 1.6, median is 4, the upper quantile is 4.5, the lower quantile is 2 point whatever value that we have seen here, 2.16. So the box plot gives us all quickly here. What is variance? We know it's a numerical measure of how data is dispersed around the mean. So let's see the formula of calculation of variance. Okay, the function is var, var, small letters, and you will know what is the variation in the data set. So this 1.3 is the variation that exists in the data set. standard deviation formula is SD duration. So we again, for the duration itself, we are getting standard deviation, and standard deviation is also under root of variance, and the value is 1.14. So earlier value is 2.2 something, and this is the under root of the same 1.14. Covariance helps us in gauging the relationship. Let us get the covariance between duration and weighting variable. Yeah, so duration and weighting variables are ready. Let's see the covariation between them. Awesome. So covariation is positive. That means they are linearly correlated and the positively correlated, not the inverse ones. But this value doesn't tell us. This tells us that it's strong enough, but we really don't know whether it's close to 1 or it's very strong or averagely strong. That will come to know when we calculate the correlation coefficient, that always has to be in between -1 to 1. So COR is the function for correlation and COV is the function for covariance. Let's run the covariation, and it's 0.90. So it automatically it directly tells us the intensity, that it's very high intensity of correlation that exists between duration and weighting variables. Central moments. So we know, right, the kth central moment, the first moment has to be always 0, and then a second moment has to be variance, and the third central moment has to be the one where we find out the skewness in the data. So to do this central moment, we need to have another library which is not the standard library, called E1071. Let's get that library on board. Okay, it's not available. We need to install the package with install.packages. Okay, so once I have got it installed, I need to call this for this library, and once I have it, I will have the moment function basically. So I'll get the first, second, third moment on the duration itself. Okay, so moment is negative. That means this curve shows the flat structure. This is not a very peaked sort of data. So remember, the third moment gives us that how much is the peaked data is. Okay, skewness of the data is defined by the formula, and the skewness is the measure of symmetry. So let's skewness is function as well. So let's do a skewness on duration. The function name is skewness. Yeah, so skewness is -4 minus 0.41 for the data that we have. So it's a negatively skewed data. Okay, let's do a kurtosis. True, kurtosis is negative. That means it's a LiPo sort of data which is not very peaked. So let's quickly see the histogram. Yeah, so this data doesn't have much peaks. It's more of a flat structure that exists in the data. Okay, so now let's do a quick example on the looping control structure, and then we'll go to the basic statistics function.